Okay, so today we're talking about parallel lines, including parallel lines with transversals going through them, three parallel lines theorem, and trapezoids with midsegments, the midsegment theorem, and midline theorem pertaining to triangles. Okay, so first we're talking about parallel lines with transversals going through them and the angles that they make. So label the angles. Now there's two different types of angles, congruent and supplementary angles. Congruent angles are angles that are the same size, and supplementary angles are angles that when put together will equal 180 degrees. The first congruent angle is alternate interior. These are angles that are in between the parallel lines and are the same size, such as 3 and 6 or 5 and 7. The next type is alternate exterior. These are angles on the outside of the on the outside of the parallel lines and are the same size, such as 1 and 8 or 7 and 2. Next is corresponding angles. These are angles that are the same size and going the same direction, such as 1 and 5, 7 and 8, and etc. The final kind of congruent angle is vertical angles. These are angles that are across from each other, such as 1 and 1 and 4, 7 and 6, 5 and 8. And that's for congruent angles. Now, like I said, supplementary angles are angles that when put together will equal 180 degrees. There are same side interior angles. These are angles like 3 and 4. They're in between the parallel lines and they equal 180 degrees. Also, angles like 3 and 5 are same side interior, and etc. Next is same side exterior. These are ones like 1 and 2 or 7 and 8. Also, just like congruent angles, you can have a supplementary angle that one's on the inside and one's on the outside, such as 2 and 4 and 6 and 8. And that about does it for supplementary angles. Now, let's do an example. Okay, so let's say these two roads are parallel, and there's a light blue paint going across them, a line of light blue paint. And you're standing right here. You measure the angle and you see that it is 60 degrees. So, knowing what you know about supplementary and congruent angles, you can find the rest of the angles. These two angles are supplementary, so you know that this is 120 degrees. This angle is also congruent to this angle. So you know this is 60 degrees. So this would also have to be 120 degrees. And knowing what you know about vertical angles, you can fill in the rest. 120, 60, and then 120, and 60 degrees. And that's just one way you can figure out all the angles of a transversal. Next, we'll be talking about three parallel lines theorem. Just like the name suggests, if you have three parallel lines, any line that goes through them will have the same ratio as all lines that go through them. So, let's say line A, B is broken up at the midpoint, so it's X and X. Any other line, such as Z, W, that goes through it, will also be broken up at the midpoint. So this would be Y, Y. But this can be anything. If this was half X to X, this would have to be half Y to Y. Now let's do an example. Okay, so let's say this tree's branches are parallel, and the three parallel branches. And we know that the vine AB is cut up so the top length is 4 centimeters and the bottom length is 8 centimeters. That means that the ratio for them is 4 to 8 or 1 to 2. So any other vine, such as ZW, will also have to be broken up in a 1 to 2 ratio. So let's say we know that this bottom length is 10, then because of the ratio, we know that the top length is 5. And that about covers it for three parallel lines theorem. Next, we're going to be talking about midsegment theorem, which pertains to trapezoids. Now basically, if you have a trapezoid like this, and you know the top and bottom base, you can find the midsegment, which is basically the line that goes from AB's midpoint to DC's midpoint. So let's call that ZW. Now equation for the length of ZW would be X plus y over 2 equals zw. Also, it makes 3 parallel lines because the midsegment is parallel to the other bases. So you could use 3 parallel lines theorem. Since line AB is broken up at the midpoint, any other line from top to bottom is broken up at the midpoint, including diagonals. So now let's do an example. So let's say an architect is designing a trapezoid-shaped building, and he wants to have an aesthetic-looking steel beam go where the midsegment would be. In his plans, he sees that the top is 70 feet long and that the bottom is 100 feet long. So he used midsegment theorem to find the length of the midsegment so he could put it in his blueprints. So he did 70 plus 100 over 2, and that came out to 85. So the midsegment is 85 feet long. That about does it for midsegment theorem. Finally, we're going to be talking about midline theorem when pertaining to triangles. So we can have triangle A, B, C. And midline theorem states that the line that goes from BA's midpoint to AC's midpoint is half and parallel to line BC. So now, let's do an example. So, let's say the same architect that was designing the trapezoid building is designing a tower that has a triangle at the point. Now, just like the trapezoid building, he wants an aesthetic looking steel beam to go across where the midline would be. So we have this. But in his plans, he doesn't have the length of that. But he does have the length of the base of the triangle, which is 80 feet. So, to find the length of the midline, all he has to do is 80 divided by 2, which equals 40. So the length of the midline is 40 feet. And that about does it for not only the midline theorem pertaining to triangles, but also to parallel lines. Thank you.